Hi. In the previous lecture, we talked about multi-criterion decision making, right? We had lots of different dimensions and you weighted alternatives according to those dimensions. In this lecture, we're going to move in a slightly different direction. We're still going to consider multiple criteria. But what we want to do is we want to have a spatial model. So the difference here is that instead of just wanting sort of more square footage or a larger lot, you're going to have an ideal point. So there's going to be sort of a perfect amount that lies sort of between too much and too little. So these are known as sort of spatial choice models. Now, spatial choice models originally started by thinking about geographic choice. There's a guy named Harold Hotelling, who's an economist, who thought about, imagine you're on a beach and there's an ice cream vendor, 50 feet to your left, and there's another ice cream vendor 40 feet to your right. You may decide, well, since the one to my right is closer, what I'll do is I'll go and, buy my ice cream when it's closer and not have to walk as far. Well, you can take that idea and you can apply it to attributes of a good. So, for example, I love Indian food, right? And I like my Indian food to be reasonably hot. We can imagine one of the dimensions then in Indian food is whether it's, cold, right, in terms of, cold in terms of how spicy it is. Or you can imagine this H here means it's really, really hot. So I could take all the Indian restaurants. I could put, one Indian restaurant here, Indian restaurant 1, Indian restaurant 2, and Indian restaurant 3, and this is how hot their food is. And so there's me as a consumer, and I'm trying to decide, okay, where do I go by? Do I buy from Indian restaurant 1, Indian restaurant 2, or Indian restaurant 3? Well, it could be that since I like my food really hot, this is my ideal point right here, I'm going to go to Indian restaurant 1 because it's closest. So this is the idea that there's, what each person has is a sort of a preference, an ideal point, and then they buy the thing or they purchase from the firm, right, that offers the product that's closest to their ideal point. So this is Hotelling's idea. There's a guy named Anthony Downs, who was also an economist that sort of moved into political science. And what Anthony Downs did is he said, we can apply this to how people vote. So what we can do is we can put politicians, right, somewhere between left and right. So maybe, this might be the Democratic candidate for president, let's say, and this might be the Republican. So both are, Democrats sort of to the left, Republicans sort of to the right, but they're not really completely extreme. And then you've got a voter who perhaps sits right here, and the voter's got to decide, okay, do I vote for the Democrat or vote for the Republican? And what they do is they look at this distance. How far am I from the Democrat? This would be distance 1. And how far am I from the Republican? This is distance 2. Remember I talked about this sort of in an earlier lecture about why we construct models. And using this model, the voter could say, well, you know what? Since I'm closer to the Democrat, I'm going to vote for the Democrat. So this is a fairly simple spatial model. Now what we want to do is we want to ramp this up a little bit. So the way we ramp this up is in two ways. One is you can take this model to data. So this is work by Andrew Gellman, who's at Columbia University. And what Andrew does is he looks at Supreme Court justices. And so here's a whole list of Supreme Court justices. I realize this is a little blurry, but here's people like Justice Blackmun, right? And here's Judge Scalia, and here's Judge Ginsburg, Justice Ginsburg. And what you can do is you can chart ideologically where they are over time, where this here is to the left and this here is to the right. So you notice that Scalia's up here on the right and Blackmun's down here to the left. So what you can do is you can sort of use this model to keep track of where the different Supreme Court justices are. What's interesting about this is then when you think about who does a president appoint? Well, the president may also have some ideal points. So if you have a liberal president, their ideal point may be down here. If you have a conservative president, their ideal point may be up here. And they're going to want to appoint a judge that has the same sort of ideology that they have. So it's really nice, very simple model, but you can take it to data, and then you can use that data to understand how presidents appoint judges, and also how the ideology of the court has changed over time. Okay, what we want to do is this. We want to sort of take this model and show how we can expand it to more dimensions. So before, right, that was just one dimension, hot, cold, left, right. But we can do the same thing in more dimensions. So let's go back, right, to the car example. Remember, I'm just trying to decide between the Ford and the Chevy, and I said, there might be two things. There might be sort of speed of the car, right, and there might be comfort, right? And once again, penmanship could be better. So, and what I do is I decide which of these two cars is closer. Okay, so let's do this in a sort of a fun example in terms of getting a burger. So let's, I like burgers, a lot of people like burgers. And we can think of, what's my ideal burger? Well, my ideal burger might have 2 pieces of cheese, and it might have 2 patties and 2 tomatoes. And also some ketchup. Let's say 4 tablespoons of ketchup, 4 tablespoons of mayo, and I'm a pickle guy, 4 pickles. So this is my ideal burger, right? And so we can write that down and sort of more carefully, right, use a better font. So say this is it. This is my ideal point. And this would be, if I do this out, it's not in two-dimensional space, like it's multi-dimensional space. I can't draw it because this is 6 dimensions, right? But this is where computers are nice, because I can code this in a computer, and it's just a vector of length 6. Well, now I've got to decide, where do I go for lunch? Do I go to McDonald's and get a Big Mac, or go to Burger King and get a Whopper? What we can do is we can say, okay, let's look at my ideal point, which is right here, and let's look at the Big Mac. The Big Mac has 2 pieces of cheese, which is great, 2 patties, which is great, no tomatoes, not so good, not enough ketchup, not enough mayo for me, and a few too many pickles. Even though I like pickles, it seems to have, a few too many pickles. So I could ask, how much do I like that Big Mac? What we can do is we can take my ideal point and the Big Mac and take the difference. So here the difference is 0, here the difference is 0, here the difference is 2, here the difference is 1, here the difference is 0, and here the difference is 2. Now notice I've got these little lines on the side of difference. That means I'm taking the absolute value of the difference. So otherwise, because there's, it's got too few tomatoes, if I put a -2 here and a +2 here, the too few tomatoes and the too many pickles would cancel out, right? So what I can do is I can add all these things up and say that my total distance from the Big Mac is 5. Let's suppose I walk across the street, and now I decide, let's see how the Whopper stacks up. Well, the Whopper has 2 pieces of cheese, that's great. It's got 1 patty, so that's off by 1. 2 tomatoes, that's great. A little, not quite enough ketchup, but perfect amount of mayo, perfect amount of pickles, so it's only off by 2. So my distance from the Big Mac, right, that, if we go back, was 5, and my distance from the Whopper was only 2. So we could, represent that by, here's the Whopper, and here's the Big Mac. This is only a distance of 2 from me, and the Big Mac is a distance of 5 from me. So what I could do is after writing down my ideal burger, I can look at the Big Mac, look at the Whopper, and say, I'd rather buy the Whopper because it's closer to me, it's closer to my ideal point. Now this is really cool because this is a thing I can use to figure out, what should I choose, what burger should I buy. Also, I can use this to figure out who should I vote for. Because instead of thinking of these as Big Macs and Whoppers, I can think of that maybe there's 2 dimensions to policy, right? So one dimension could be some sort of social policy between liberal and conservative, and there could be some sort of fiscal policy, right, between liberal and conservative. So this would say I'm sort of socially liberal, but on fiscal dimensions I sort of lie in between liberal and conservative. And so this would be my ideal point, not in sort of Big Mac Whopper space, but in political space. And then what I could do is I could vote for the party or the candidate that's close to me. Another thing we can do with this model, and this is sort of cool, is, remember we talked about how we can use this positively. So suppose I watch one of my friends, right? What I mean by positively, right, is to figure out, to explain why we see what we see. So suppose I watch one of my friends and I go in and I see that my friend doesn't go to Burger King. My friend goes to McDonald's and gets the Big Mac. But I don't know anything about my friend's ideal points. But I do know about the Big Mac and the Whopper. Well, notice the Big Mac and the Whopper are the same on this dimension, this dimension, this dimension. Same amount of cheese, same amount of ketchup, same amount of mayo. So what I could do is I could say just wipe out those categories, right? Because they're the same. And then it comes down to number of patties, tomatoes, and pickles. So now if I see my friend buying the Big Mac, what can I infer? I can confer either that they like sort of 2 patties, or that they don't like tomatoes, or that they really like pickles, or some combination of those things. And so what I can do by looking at choices, I can understand what someone's ideal point is. And again, once we've got this idea in our head, we can go to data and we can figure stuff out. So for example, let's look at political parties. So what you can do, and this is a map by Michael Tofias using some data from Poole and Rosenthal called nominate scores. And what this does is it takes every single member of Congress and it looks at all their different votes. Now, based on their votes, you can figure out how conservative are they and how liberal are they. Now, nominate breaks things down into 2 dimensions. So you think of this being 1 dimension, another dimension. So just for our purposes, let's suppose this is a social dimension, right? And this is a fiscal dimension, right? So this is money up and down here, right? And this is more policies on this dimension. So what you see is look, all the Republicans lie to the right on the social dimension, and the Democrats all lie to the left. And if you look at, this is a particular map looking at the Tea Party, which is a movement within the Republican Party, and if you look at the Tea Party, people are pretty well evenly mixed. So what you can do is by taking this modeled data, right, you can figure out by looking at the choices people made, this is sometimes called revealed preference, you can look at the choices people make, in this case, politicians voting, and you can map out where they are ideologically. So you can notice the Democrats are all to the left of the Republican on social issues, but on the fiscal dimension, it's a little bit more complicated, right? Okay, so that's spatial models. They're really cool, right? We can use spatial models to figure out sort of what we should, where we should buy Indian food, who we should vote for, which car to buy, whether to go to Burger King or McDonald's, right? By looking at these dimensions and seeing how close something is to our ideal point. Now, we can also take these models to data and do more serious things. We can figure out, where Supreme Court justices are and where members of Congress are ideologically, whether it's on one dimension or on two dimensions. We can do the same thing for products, right? So we could do that same sort of mapping and look at different products in space, whether it's types of coffee, right? Whether it's types of automobiles, and we could look at people's decisions on which to buy, and we could figure out sort of where people's preferences really lie based on the cars they buy or based on the coffee they buy. So the spatial model is really powerful, helps explain what people do, and helps us make better choices ourselves. Thank you.